Okay, hello, good evening. Hi, Gabriel. There's only you to so far. Okay, welcome anyway. So shall we wait for them? I'm not too sure. Okay, so let's begin first. Let's begin first. I believe it will come in soon. Hopefully sooner rather than later. Right. Yeah. So where were we? Oh, right. We are in this chapter 8. Okay, we're in this chapter 8. All right, so I think we finished the drawing of electron last week. Okay, yes, Lara, hello. Good evening. Nice to see you. Don't see you quite often. Right, anyway, yeah, so where's the rest of them? Anyway, so I think we stopped around here. I think we finished chapter 8.2 last week. Okay, we did draw all these electrons. Okay, what determines something is reactive or not? Okay, by looking at this thing called the valence electron, the outermost electron, right? As I said, if they are electron 1 or 7, they are freaking crazy because they're trying to be full. Every atom's job, okay, every atom's job is to become either duplet, that means they fill up the first shell, or they want to become octet, that means they fill up the second shell, right? If they do so, then they're happy. Okay, if they fill up everything, then they're happy. So if they're not full, like sodium is very unhappy because he has one extra here. Sodium really wants to throw this one away. And then chlorine is also very unhappy because chlorine needs one more. Okay, so if you're so close towards perfection, then of course you are more desperate to get there. You get what I mean? All right, so I think we mentioned this also last week. Okay, this is our main point today, guys. This is our main point today. So nucleon number equals to proton number plus neutron number. So what is this? When we look at an atom, the middle of the atom is what we call nucleus. Remember? Okay, this is what we call nucleus. So nucleus is the middle of an atom. It's just like, okay, it's just like, okay, sorry guys. Okay, anyway, so it's just like the middle of a cell is a nucleus, right? The middle of a cell is a nucleus, so the middle of an atom is a nucleus too. And do you see there are two colored balls here? You have the blue color balls, which is the positive one, we call it proton. Okay, guys, you learn this in Form 1, and you have the yellow color ones, we call it neutrons. Okay, so in order to get the full number, we have to add all the blue ones and all the yellow ones together, right? Right? So this is the formula. Okay, this is what I asked you to wrote down last week. Nucleon number, which is the total number, the nucleus number, nucleon. So the total number is the blue ones, which is the proton, plus the yellow ones, which is the neutron. So proton plus neutron, blue plus yellow, you get total. Okay, you get total. This is what you need to know for today. And I kind of mentioned this last week. And then we did mention that last week, proton number is the ID number or the IC number. Because proton number tells you what the element is. Like I said last week, sulfur is IC number 16. That means the number 16 will forever be sulfur. Let's say your IC number, okay, let's say your IC number is 5315. Let's say that 5315 will forever be you. There's no one else unless someone clone you. So same thing. 16 will forever be sulfur. Okay, 1 million years ago, 1 million years later, 1 million years in the future, they will always be 16. Okay, so that's the proton number. So this is why, right, when we arrange our periodic table, we follow our proton number. We follow the IC number. Okay, we follow the IC number. So this is a list of people. So we just arrange them according to the IC. We don't use these two numbers because they don't really mean anything. Okay, we don't use these two numbers. But today we do. Today we do. Okay, let's go to our 8.3. This is what we want to learn today. Oh, sorry, let me cancel this real quick. I forgot to erase this yesterday. Right, so let's talk about 8.3. So let's talk about isotope. This is what we're going to learn today, isotope. Now, what is an isotope? Isotopes, they are the same elements with the same number of proton, but different number of neutron or nucleon. Please write this down. Either neutron or nucleon. That means isotopes, they are the same element. Like I said, same element should be same proton, right? All right, for example, let's look at proton number 1. Who is IC number 1? Who is IC number 1? IC number 1 is hydrogen, right? Hydrogen is IC number 1. No one else, okay? 1 is definitely hydrogen. But then you see, hydrogen, okay, you see proton number 1, right? It's all hydrogen. But you might say, sir, you say there's only 1 hydrogen, right? Why got 3 1? Why got 3 1? So isotopes, they are sort of like clones. They're sort of like clones. So this hydrogen, right, turns out it has 3 people there. You might say, why got 3 1? They are somehow the same person, but somehow they are not. Okay, I know it makes no sense, but this is the meaning of isotope. They are the same element with same number of proton, because same proton means same element, but different number of neutron or nucleon. That means, right, according to this formula, they have the same proton number, but different neutron number. If the number of neutron is different, nucleon is definitely different, right? Okay, take for example, if proton number 6, but neutron number 6 and 7, so 6 plus 7 is 13. 6 plus 6 is 12, right? So you see, same number of proton, different number of neutron, and if it's different number of neutron, it is different number of nucleon. Okay, different number of nucleon. So the same thing lah. Okay, the same thing lah. Okay, you get what I mean, Okay, yes, Jala, hello, good evening. Okay, you're a bit late, so we are halfway through, So as I mentioned, if you have the same number of proton, different number of neutron, you have the different number of nucleon too. All right, so let's go to this again. All right, so like I said, if you're IC number 1, you are for sure hydrogen. But then again, you have 3 types of hydrogen. You have hydrogen 1, you have hydrogen 2, you have hydrogen 3. Okay, can you see there are 3 columns here? You have number of proton, you have number of electron, number of neutron. Okay, please add one more. You have number of nucleon. Okay, you have number of nucleon. And then electron, right? Like I said, this is what we learned last week. Electron and proton is always the same, because how many plus, that means you have how many minus. So this is not needed. Because you see 1, 1, 1, 1, 1, 1, 6, 6, 6, 6, 6. So doesn't matter. Okay, doesn't matter. So we don't really look at electron. We only look at electron when we want to draw this thing. Okay, but we don't. We did this last week, so we don't care about electron. All right, so let's talk about this proton. Since they're all 1 proton, they are all same element, they are all hydrogen. But you see, neutron is different. Some hydrogen, they have 0 neutron, some has 1, some has 2, which makes it very funny, because if you look at the nucleon, so proton plus neutron is the nucleon, right? So 1 plus 0, 1. 1 plus 1, 2. 1 plus 2, 3. So you see, remember our definition just now? Same number of proton, different number of neutron or nucleon. So as long as they are isotope, they have the same number of proton, different number of neutron or nucleon. You see, when neutron is different, for sure nucleon is different lah, because this plus this is this one. So when this is different, the answer is different. So this 1, 2, 3, right? This 1, 2, 3, right? They are the nucleon. Okay, so this is me telling you, this is me telling you, when you see isotope, when you see the number behind, that's the nucleon number. That is the nucleon number. All right. So there's actually 3 hydrogen. Hydrogen has 2 more clones. All right. Like I said, if you have the IC number, let's say your IC number is 5315. 5315 is only you. But somehow, if you manage to clone yourself, then that IC belongs to 2 people. One you and another is as your clone. So hydrogen, that's the case. All right. So for hydrogen, there are 3 clones of them, but they're somehow a little bit different. The neutron and the nucleon is a little bit different. Right. Same goes to carbon. You see, all carbons, they are proton number 6, because according to our IC, carbon is IC number 6 for sure. That means number 6 is always carbon. 1 million years ago, 1 million years later, it is always number 6. So your carbon has 3 types. You have these 3. So you have same proton number, different neutron number. So you have 6, 7, and 8. And we add them together, 6 plus 6, 12, 6 plus 7, 13, 6 plus 8, 14. So you have 12, 13, 14 nucleon number. That's why you have different carbon, which is carbon 12, carbon 14, and carbon 13 and carbon 14. Okay, you can understand? You can understand? Very easy, huh? Very easy, huh? Yes, China, hello, good evening. How are you? Okay, so we are in 8.3, isotope. So let me repeat this again. Isotope, they have the same proton number, but different neutron number or different nucleon number. Okay, China, try to catch up, okay, because we are almost done already. That's the main concept of talk about today. Right, so like I said, isotopes, they are clones. Okay, they are clones. They are almost the same as each other, but they're just clones. They have the same IC number. Like I said, proton number is the IC number, but they have different total number. So oxygen is the same thing, you see. Oxygen, you have oxygen 16 and oxygen 18. So both of these, they have the same number of protons, same IC number, but different neutron number and different nucleon number. So 8 plus 8, 16, 8 plus 10, 18. So 16 and 18, oxygen 16 and 18. Like I said, this is the nucleon number. Okay, the 16 and the 18, they are the nucleon number. Okay, can you understand? Guys, this is just basic addition and addition and subtraction. So because of this thing, we learned this last week. Nucleon equals to proton plus neutron. We wrote this down last week. All right, so this is why we care about the neutron, okay? Because so far we learned this chapter, we don't really pay attention to the neutron, right? So now we do. Now we do. All right, so this is what you need to know. Yes, Neha, hello, good evening. I just finished my point already, then you come in. Right, so this is your isotope, guys. Very easy. If you see isotope, here's the thing, guys. Isotope will for almost certainly come out in an exam, and it's a for sure score in exam. Because it's so easy. Guys, you don't want to add 6 to 6, then I worry for you. It's okay, as long as you're here. All right, so same proton number, different neutron or different nucleon number. Okay, you try to you do try to catch up, okay, because I've like finished this already. All right, so this is the nucleon number. So you see, same proton number are these 3, they are isotopes. Hydrogen 1, 2, 3, they are isotopes because they have same proton number, same IC number, but different neutron number or different nucleon number. These 2, they are different, but proton is the same. Okay, like I said, same proton means same element. Same IC means same person. Easy to understand. So you do this, same thing. So you see, chlorine 35, chlorine 37. As I said, these numbers, they are your nucleon numbers. So 35, 37, that would be 35, 37. Right? And then Let's calculate the proton number. So the total number is 35, right? Neutron is 18, right? What about proton? That will be 17. Because this plus this equals to this one. Right? We talked about this last week already. Okay. Nuclear number equals to proton plus neutron. Okay. Total number equals to blue plus yellow. Total number equals to blue plus yellow. That's the meaning. Right. So since we have 17 plus 18 equals to 35. Okay. Blue plus yellow equals to total. Right. So since they are the same element, right? Both are chlorine, right? So the IC number should be the same. Okay. If someone has the same IC number as you, that person is you. So same chlorine. And then 17 plus what equals to 37? That would be 20. Okay, you understand? Can you understand? Guys, please don't get this section wrong. It's very embarrassing. You cannot even do addition, man. Okay, so sodium 23 and 24. So that's the nuclear number. So you have 23, 24. So 11 plus 12 equals to 23. And then 11 again, because same IC number, 11 plus 13, you get 24. Right, so same thing, bromine 79, 81. 79, 81, they are your nuclear number, 79, 81. And then same person, same IC number, so same 35. Okay, same 35. So what about this? Basic subtraction. So 79 minus 35, you get 44. And then 35 plus 46 equals to 81. All right, I hope you all get this. I hope you all get this. Today there's no drawing, nothing. It's basic maths. Proton plus neutron equals to nucleon. If they have the same proton number, different neutron or nucleon, they are called isotopes. Okay, isotope. Isotope basically means clones. They are the clones of the same element, but they are just somehow a little bit different. So what about their characteristic? They have the same chemical properties, but different physical properties. Why same chemical properties? Since they have the same number of electrons, they have the same properties, they have the same configuration. If it's sodium 23, they are still 2.8.1. If they are sodium 24, they are still 2.8.1. So they have the same chemical properties because they have the same valence electron. Okay, this is last week. Okay, not related to this week. Right, so they have different physical properties. This one not really important. All right, so let's talk about the use. What isotopes are useful? This one you need to memorize. Okay, but when you see this table, before you freak out, sir, do I need to memorize all? Close to it, but it's not as hard as you imagine. Okay, here am I. Okay, let me simplify this for you. That's my job, isn't it? Right, so guys, let's look at some famous isotopes. Where do we see them? Right, first of all, I want you guys to highlight sodium 24, iodine 131, and phosphorus 32. Please highlight these three. They are your tracers. Okay, please write it down. They are your tracers. Do you know what are tracers? Do you know what are tracers? Things you use to trace something. What do I mean? Let's say I want to know where you live. Yeah, I want to know where you live. I want to follow you home. Instead of me stalking you, okay, and arouse your suspicions, might I just put a GPS device on your car? Under your car. Okay, I just put a GPS device under your car. Then I can trace your road back to your house. Then I know where you stay. All right, so that's the function of tracer. Okay, that's the function of tracer. So okay it's like you switching on your location on your phone The Google will always trace you. They will know where you are. Right, so these are tracers. So what tracers are we talking about here? Let's talk about sodium 24 first. Right, sodium 24 can be used to trace two things. Number one is underground pipe leakage. Please write it here. Okay, underground pipe leakage. Second is to trace blood clot. All right, so what is this? Let's just talk about underground pipe leakage. For example, right, let's say you have an oil rig. Okay, I don't know how to draw oil rig. Okay, I just draw it this way. Okay, you know what's an oil rig, guys? You know what is an oil rig? It's the place that digs oil from the ground. Wait, what the hell is this? Okay, oil rig. Oil rig is, oil platform, okay, whatever. This is the place where they get petroleum from the ground. All right, so do you know how they ship this thing to the ground? They will build an underground pipe system, okay, to the processing facility. Let's say this is the factory. Okay, this is the factory. So once they get the petroleum or gas from the ground, they will ship it to the factory. And this thing can be really long, like maybe 100 kilometers. Okay, 100 kilometers. Right, here comes the problem. If let's say there's a leakage somewhere here, you want me to dig up all this soil just to see where the leakage is, right? That would be really stupid. Would you want to dig up 100 kilometers worth of soil? No, you don't. Right? So that's a really stupid thing to do. So instead of doing something so dumb, why not we just use a tracer? Because you see, when I put sodium 24 at the source here, the sodium 24 will go through the pipe. And if let's say there's a leakage here, sodium 24 will leak out from here. Okay, sodium 24 will leak out from here. Right, something about all these isotopes, they are radioactive. Okay, do you know what is radioactive? We call it radioisotope. Radioactive means they will produce dangerous radiation and they are very easy to detect. All right, somehow, guys, for some reason, radiation, they will glow up when you put X-ray or gamma ray on it. Okay, or when they go inside the MRI. Okay, so you just need to use any radiation detector. You just scan this soil all along. When you scan the soil and you find, hey, why are there so much radiation here? Okay, why is there so much radiation here? Then you know the leakage is around here. You see how smart this is? We are using the sodium 24 as a tracer to know where the leakage is. Okay, so not only that, not only we can use it on underground pipe, we can use it on our body pipe, which is our blood vessel. So we can use it to detect blood clot. Let's say now you get heart attack, right? There's a blood clot in your heart. The doctor has no idea where it is. So they will ask you to drink this sodium 24 and then they will put you inside an MRI machine. You know what's an MRI machine? The magnetic resonance imaging machine. This one. Okay, so they will ask you to sleep inside an MRI and then the part that has the blood clot will glow up. So they will know where your blood clot is. Again, you see, tracer. To trace where your blood clot is. To trace where the underground pipe leakage is. Tracer. Okay, easy, so sodium 24 is a tracer. It is a tracer, not only for us humans, okay, it's for underground pipe too. Right, next tracer, you have iodine 131. What the hell is this? If you still remember what is iodine, iodine is a nutrient needed by your thyroid. You learned this last chapter. Remember your thyroid gland? Your thyroid gland will produce something called thyroxine, which controls your metabolism. Okay, and you actually learn this in Form 2. Because to keep your thyroid healthy, you need iodine from seafood or seaweed. Okay, seafood or seaweed. If you don't eat enough iodine, you are going to get goiter. Goiter. What is goiter? Goiter is the swelling of your neck. Okay, so goiter is the swelling of your neck. The swelling of your thyroid gland, you see? That's your goiter. So how do I know whether you have goiter problems or not? I just ask you to drink iodine 131. If this part glows up when you sleep inside MRI, like just now the sodium 24, if you go inside the MRI, if your thyroid gland glows up, that means there's a lot of iodine 131 here. that means your thyroid gland is very healthy. Okay, that's your iodine 131. Right, next, you have your phosphorus 32. Again, the same thing, but this is for plant because fertilizer has phosphorus, okay, in the form of phosphate. So whether a plant is absorbing phosphorus well, we can do the same thing. So when plant, they absorb this, the plant will glow up. Same thing, you see, when we have blood clot, our blood clot will glow up with sodium 24. When we have sodium, when we have iodine 131, our thyroid will glow up. When we have phosphorus 32, the plant will glow up. So you know, is the plant healthy or not? Are they absorbing phosphorus in a usual way or not? So you know lah. Okay, yeah, guys. So these are tracers. These are tracers. We use it to trace things. So this carbon 14 you can ignore. Okay, carbon 14 is another tracer. Okay, another tracer, but mostly this is not coming in exam. Right, next, cobalt 60. Okay, if you see here, cobalt 60 has 2 here. So what is the function of cobalt 60? Cobalt 60 is very good in producing gamma ray. You actually learned this last year. Gamma ray is one of the most dangerous radiation in the world. What is it for? It is used to kill things. Okay, it is used to kill things. So cobalt 60 in medicine, it is used to kill cancer cell. Okay, guys, do you know what is radiotherapy? Do you know what is radiotherapy? If let's say today you get cancer, right? Okay, touch wood lah. Let's say you get cancer, you will usually go through 2 treatments, which is chemotherapy. Basically, they put chemicals inside you, okay, chemotherapy, and then you have radiotherapy. That means they use a radio wave, a very dangerous wave, to zap your tumor away, hopefully. Okay, so in this case, we use cobalt 60. Okay, cobalt 60. We use it to zap away your cancer cell. Not only that, we can also use this to zap away bacteria. Okay, zap away bacteria. You might say, sir, then can I use this to kill bacteria in my house? Yes, you can, but usually UV is enough lah. Gamma is a very overkill. But who does this? Okay, who does this? This is mostly for export. Okay, mostly for export. What do I mean? Let's say now you are going to export strawberries. Okay, let's for example, strawberries. You know that strawberries, they don't last long. Okay, they don't last long. Once you pluck the strawberry from the tree, you have to package it, put it on a truck, put it on a plane, fly to another country, get down from the plane, get away from the truck, put it on a shelf. So the whole process, it could take days. Okay, and maybe by the time they are on the shelf, they are not so fresh already because of the bacteria. So before they export strawberries, right, or any fruit for that matter, before they export, right, usually they will use gamma ray and disinfect the fruit to kill all the bacteria on it before they package it. Okay, doesn't mean that the fruit won't spoil, but they will last much longer because there's no more bacteria. Okay, yeah, the bacteria can still come in and grow, but at least you kill the first batch first lah, so it can last a little bit more longer, maybe 2 more weeks long, 1 more week longer, 2 more weeks longer, I don't know. So it's used to kill bacteria too. So as you can see, your gamma ray, your cobalt 60, they are good in killing cancer and good in killing bacteria. Right, so so far we have memorized half of it. Okay, next, what is carbon 14? Carbon 14 is only used for carbon dating. Carbon dating. What is carbon dating? Carbon dating is to estimate the age, the age of fossils. Right? Have you ever wondered this? Have you ever wondered this? Sometimes you see it on the news. Oh, new dinosaur bones found. Scientists claim to be 500,000 years old. Then you are scratching your head thinking, how do they know? Okay, how can they tell? How can they tell whether something is a fossil or something is just fake fossil? They just look at the carbon dating. They will just need to scan carbon dating. By scanning the fossil or whatever for carbon 14, they can roughly know how old the fossil is. Okay, so this is how they piece things together lah. This is how they piece things together. How do they know? Oh yeah, by the way, guys, common misconception, T-Rex, they don't live in the Jurassic era. Okay, in the Jurassic era, you know, when you watch Jurassic Park, Jurassic World, falls, you don't actually see T-Rex there. T-Rex actually belongs to another era. When you, let's say if you take time machine and you go back to Jurassic era, you can only see Stegosaurus. You know, the big the big herbivorous dinosaur, the one that has spikes on the back. That's the Stegosaurus. Okay, they actually live in different era. And funny enough, T-Rex is actually closer to human existence than Stegosaurus existence. Okay, that means if you were to ask T-Rex, they don't even know who Stegosaurus is. I mean, provided if they can talk lah. Okay, theoretically speaking, okay, they have never seen Stegosaurus before. How do scientists know this? They just piece together the fossil by doing carbon dating, by scanning for the carbon-14. Okay, they use this to determine many tombs in ancient Egypt. Okay, how what year did Tutankhamun died? Okay, you know who is King Tut? Okay, Tutankhamun. Okay, he's like the mysterious pharaoh's mummy that we couldn't find for the longest time until, like, you know, 50, 60 years ago, I think. All right, so that's your carbon-14. Okay, carbon-14. And then americium we can ignore, not important. And then uranium-235, this one you learned it last year. Uranium-235 is for power station. Okay, for power station. Or you can use it to make nuclear bombs. Okay, if you have uranium-235, you can use it to make nuclear bombs. We don't have it, so we can't make one. That's why we can't use power station. We can't make nuclear power station. All right. Japan, they can use nuclear to power their country because they have uranium-235. We don't. Okay, we don't. So you can use it to make bombs too. All right. So anyway, so these are the isotopes that you need to memorize. Not so hard now, isn't it? Okay, I already basically summarized everything for you. Okay, these are the traces. These are the ones you to kill bacteria. And then you have carbon-14 and uranium-235. That's all. Okay, that's all. Pretty much it. Okay, pretty much it. Yes, you need to memorize this. And yes, they will be coming out. And it's not hard. Okay, I don't know. For me, it's not hard. It's, you know, it is what it is. Very straightforward. Right. So I think we believe I believe we have finished all. Yeah, I believe we finished chapter 8. Right? Okay, so it's easy as it gets. So let's go to our exercise, shall we? Let's go to our exercise. We did the drawing last week, so let's do question 17 today. Okay, sorry, I forgot to erase this yesterday. Right, so let's go to question 17. Question 17. So we do the same thing just now. So you see, same proton number, same element. So this number, that's the neutron number. Okay, so 1 plus 0, 1, 1 plus 1, 2, 1 plus 2, 3. So 12, 13, 14. You don't even need to calculate this. 12, 13, 14. Okay, 12, 13, 14. Because 6 plus 6, 12, 6 plus 7, 13, 6 plus 8, 14. Okay, end of story. So what is nuclear number? Like I said, nuclear number is the sum of proton number and neutron number. These two add together, that's your nuclear number. Okay, that's a nuclear number. So next, give one use of isotope. Do this yourself lah. What do we use in medicine? You have sodium-24 to detect blood clot. You have cobalt-60 to kill cancer cell. You have iodine-131 to detect thyroid activity. Choose one. Okay. And then agriculture, I believe we only study one here. That would be your phosphorus-32 to detect the absorption of fertilizer or phosphate fertilizer. That would be your agriculture. Okay, so correct use, okay, match with the correct use. So carbon 14, like I said, what is carbon 14 for? Is to detect your fossil, okay, to do carbon dating. So to estimate the age of your artifact. Phosphorus 32, just said it, this is to determine whether a plant is absorbing fertilizer well, okay, absorption of phosphate. Cobalt 60 to kill cancer cell. Sodium 24 to detect pipe leakage. There. It's not mentioned in the notes, but it's in the question. Right, so next, question 18. Solve the following problems regarding isotope. Right, so the number of proton in carbon 14 and 13 is 6. Find the number of neutron. So this is the nucleon. Okay, so this is the nucleon. We know that nucleon equals to proton plus neutron, right? Okay, so if the proton is 6, okay, if this is 13, 14, so 6 plus 8 is 14. So the neutron for carbon 14 is 8. Okay, 6 plus 8 is 14. Hope you understand this. Very easy maths. So 6 plus 7 is 13. So 8 neutron, 7 neutrons. All right. B, a fluorine atom has 9 protons and 10 neutrons. What is the proton number and nucleon number of the atom? Proton number is 9 lah. Okay, what are they asking there? And then the nuclear number is the total 9 plus 10, so 19. Here's the total. Okay, so C, an atom has 10 proton, 10 neutron, 10 electron. Okay, we don't care about the electron because it's the same as proton. What's the nuclear number? So the total, that means 20. 10 plus 10, 20. All right, so next. So D, diagram below shows the use of radioactive substance in food preservative. I said, they do this to potato. They do this to potato. Yeah, one more thing, guys. You know that when potato they germinate, it's poisonous to eat, right? So somehow, when you zap potato with gamma, right, it slows them from germinating. Okay, this is why your potato, okay, your potato, let's say you buy potato back from a supermarket, usually you need to put them around for 3-4 weeks, only they will start to germinate. Okay, because they use gamma to kill their, the small young potato plant already. Doesn't mean that they will die, it's just that they will germinate slower. So state the function of gamma radiation. So we can say to kill bacteria. Okay, 2 use of gamma radiation. Okay, you can use to kill cancer cell. What else? 2 use. I don't know. Used to become the Incredible Hulk. I don't know. There's no more use. Guys, by the way, if you watch Marvel, this is how Bruce Banner become the Hulk. Okay, he zapped himself with gamma ray, and then his cell starts to mutate, and then when he gets angry, it turns green. Guys, if you use gamma ray to zap yourself, you are not going to become the Incredible Hulk. You will get cancer. Okay, it's comic, guys. Don't take it too seriously, please. Okay, so 19. Table below shows the number of proton, neutron, and electron. So proton and electron is the same. You just copy back. So 6, 6, 6, 6, 12, 12, 18, 18. We don't really care about this column. We care about the neutron because this plus this equals to the nucleon. So they want the nucleon already. So 6 plus 6, 12, 6 plus 7, 13, 12 plus 12, 24, 12 plus 17, 29. All right, so you see, C is their favorite question. They love asking this in exam. They will give you any PQRS element. They will give you the number of proton. So they will ask you, state a pair of isotopes. So who amongst here, they are isotopes? Then you have to look at who here is the same person. All right, so that would be P and Q, right? Because they're the same proton number, same person, same proton number, different neutron number. Okay, I mentioned this already. So that would be your P and Q. So explain your reason because they have the same proton number, different neutron number. You want to say nucleon, yeah, fine as well. Same meaning. So different nucleon number, different neutron number, but same proton number. Okay, both are 6. So 2 use of isotope. Choose 2 lah. Choose 2 lah. There's even like what 6 here. So just we quickly do this. What is carbon 14 for? This is for your fossil. Phosphorus 32, phosphorus in plant. Iodine 131 for your thyroid. Cobalt 60, destroy bacteria. Uranium 235 for electric, to generate electricity. Americium 241, the one I told you not important. This is to measure paper thickness. Wow. As easy as it gets, okay? Nothing tricky here. What you see is what you get. Right, B, so activities that involves radioisotope. Obviously, this is your radiotherapy. This is archaeology. So what is used here? So this is cobalt 60. Q is your carbon 14. Right, so one effect of nuclear explosion. Why is it here? Hey, we skip this. Not important. What is the material used to keep radioactive? This is Form 3. Why is it here? Okay, not important. Name the radioisotope in nuclear power station. This would be your uranium 235. Okay, so the energy is called nuclear energy. Okay, nuclear energy. Okay, so we have a bit time left. Let's go back to up there. Okay, let's finish this because we have some leftover. Oh, let's go to question 14, guys. Let's go to question 14 because we have done question. Have we done 13? No, we haven't done. Let's go to 14 lah. Yeah, let's go to 14. This is also a very typical exam question. They will give you 3 elements. Okay, X, Y, Z. Okay, they are not real elements, they are fictional elements. Okay, so usually when you see an element, the top number is the proton, the smaller number is the nucleon. Right, they don't write the neutron number because neutron number you can just take nucleon minus proton. That's your neutron number. Okay, so what is your nucleon number? Again, like I said, it's your proton number plus your neutron number. And then B, write the electron arrangement for X, Y, Z. Okay, so this one very easy. Or X, Y. Okay, so you see this is the proton, right? How many protons means how many electrons? I said this already. 2 proton means 2 electrons. So 2 electrons, right? How are they arranged? X is arranged like this. Just 2. Okay, because they have 2 electrons, right? They fill up the first shell. End of story. Second shell, nothing to fill. So X is very happy. X is very stable because the first shell is full. And Y is 16. So how do you arrange 16? You arrange it like this. 2.8.6. Because 2 plus 8 is 10. 10 plus 6 is 16. So 16 proton, 16 electron. How do they arrange 16 electron? They put 2 in the first shell. And then they put 8 in the second shell. And then the remaining 6, they put it in the third shell. So 2, 8, 6. So Y is actually very reactive because you see, Y, right, needs 2 more to be full. So Y will go and take 2 more from other people. That's why they're reactive. And if they ask for Z, Z is 2.8.7. Because 2 plus 8 is 10. 10 plus 7 is 17. So Z is even crazier. Z is even more reactive. Very, very reactive. So C, state the number of electrons present in the atom of element X. So how many electrons here? So 2 lah. Why? Because same as the number of proton. Like I said, proton and electron number is always the same. How many plus means I have how many minus. So in this case, X has 2 proton. That means it has two electron. Okay, because if there are different number, guys, if there's more proton than electron or more electron than proton, we don't call it atom, we call it ions. Remember, when I take electron, I throw electron, I become less or more than proton, then I am called an ion. So very different already. And then D, state the number of neutrons present in the atoms of element Y. Okay, number of neutrons here. Explain how the answer is obtained. So you have nucleon, you have proton. So nucleon minus proton, you get neutron. Okay, neutron, 32 minus 16, you get 16. Okay, so E, which atom will form ion? Explain the formation by sketching the box below. So there's actually 2 here, which will form ion. Definitely not X, because X is happy. Y will form ion because Y needs to take 2 more electron. Z needs to take 1 more electron to become full. So this is last week, guys. This is last week. So Y, they will 2.8.6, right? Okay, this is Y, right? 2.8.6, right? So how do they become happy? They will take 2 more and they will become 2 negative. 2 negative. We mentioned this last week, right? They become 2 negative because they need to take 2 more to become happy. Whereas Z, almost the same thing. They have 2, 8, 7. Okay, so this is Z. Are they happy? No. Z has 1 more spot here. So Z will die, go and take 1 more electron, rampas another electron for other people, okay, from another person. So they will become negative. Okay, 1 negative in fact, but we don't write 1 in chemistry, we just write negative because we say H2O, we don't say H2O1, we don't write 1. So these 2, they will become ion. So you become Y2 minus and Z minus. Right, so I hope you understand this. I hope you understand this. Okay, very easy stuff. Very easy stuff. So let's, this is rather easy though. Okay, let's just do 15. We finish this as we go along. So X will throw 2 electrons to Y. So X will become 2 positive. Y will become 2 negative. Because I throw 2 negative to Y. So what type of ion will X form? It will form a positive ion. Identify the element represented by X. So what kind of element is this? X is a metal. How do I know it's a metal? Usually metal will throw electron. Okay, the one taking electron will be non-metal. Usually is that meaning. What type of ion would Y form? Okay, they will form negative ion. Explain. Why do they become negative? Because they receive 2 electrons. They receive electron. When I receive, I become negative. Because electron itself is negative. When I take 2 negative, I become negative. When I throw away my negative, I become positive. Right? So element represented by Y usually is a non-metal. Non-metal. So what is element? We said this already. X is metal. Why is a non-metal? Okay, so next, the same question. We have lithium. They throw one electron away. They become positive. So arrangement for lithium. Lithium is 2.1. You see, first shell has 2. Second shell has 1. So 2.1. Electron arrangement for lithium ion. Okay, atom is 2.1. Ion is 2. Because I throw 1 away already, now I become ion. It's 2. So charge of 3 proton is 3 plus. 2 electron is 2 minus. Total charge is plus 1. Okay. We skip this question, not important. So the same thing for oxygen. Oxygen is 2.6. Outer shell was 6. So they take 2 more to become 2.8. So oxygen atom is 2.6. Oxygen ion is 2.8. So they become negative. They take 2 electrons to become negative. This is last week's stuff. It is last week's stuff. So yeah, I think I'm going to stop here. Okay, because there's nothing else to do already. The rest you can do yourself. Okay, yeah, we have 4 more minutes, right? We do one more. Let's go to question 6. Let's go to question 6. Okay, just sort of like a revision for a periodic table. So P, Q, R, S, T, U. So there are like 6 elements here. Okay, they are used to represent elements in the periodic table. How are these elements arranged? Like I said, how do you arrange elements in periodic table? Okay, according to increasing IC number, increasing proton number, left to right, top to bottom. Okay, left to right, top to bottom. B, which elements belong to the same group? So what is group? Group is coming down, right? So who's the same group? There's only 2 here, P and U. Okay, P and U. Then C, which element exists as stable? So who is stable? Like I said, stable is on the last group, group 18, when they have full everything already. So that will be your R. Next your answer, because they have octet electron arrangement. That means they are full on the outside. They have 8 electrons on the outside. They are very happy. So D, an element has neutron number 32, proton 16. Where is the element located in non-periodic table? So 2.8.6. They are in period 3 because they have 3 layers. And then this is 6, right? Like I said, how many is at the last? That means they are in what group? So 6 electron, they should be in group 16. 16. Why not 6? Because like I said, from 3 to 12, we don't count. So it's from 1. If my valence electron has 1, group 1. 2, group 2. 3, group 13. I jump to 13. And then 14, 15, 16. So it should be 16. Group 16. Right, so state the electron arrangement. So P, right? This is 1, this is 2. So P is 2.1. That's 3 electron. You just tell me how many electron first. Okay, P has 3 electron because it's 3 proton. Q, okay, 3, 4, 5, 6, 7, 8, 9. So Q has 9. T has 9, 10, 11, 12, 13. T has 13. So how do you arrange 9? 2.7. That's 2 plus 7. 13, 2.8.3. Okay, so that's all. Okay, that's all. So I officially wrap this chapter up, which is our chapter 8. Next week, we shall start with chapter 9. I hope you can understand this chapter because this is a chapter that is really easy to score in exam. So please spend more time here, okay? Because it's really worth your time, you know, getting marks here. All right, so guys, I hope you have a happy Wednesday. Okay, I will see you again next week lah. All right, so see you again. Take care. Goodbye.